Assalamu alaikum guys. How is everyone? Can you guys hear me? Okay, thank you so much. First of all, thank you Mudassir for this nice introduction. I welcome everyone in today's session where we're going to have the hands-on implementation how we can deploy your machine learning model into the cloud platform so you can make the machine learning model available for your organization for anyone in your organization or outside the organization. So if they have to utilize your machine learning model within easy deployment, they can access it. So let's start our session without any delay. Let me start sharing my screen. You guys can let me know if you guys can see my screen. If you guys can't see my screen, also let me know. So today we are going to see how to deploy a machine learning model. Our today's agenda is we're going to see the introduction to cloud. We're going to see what are the services available in the cloud, not only for the machine learning, for the rest of the things, what you can use if you are working in a cloud, if you are planning to be expert of the cloud architecture, the cloud solution architect, what are the things you need to explore, what will be the services you're going to explore. So we're going to have the introduction about all these things. Then we'll see how we can perform the machine learning model training, which is new for maybe new for some of the people, but those who have already joined have was in our previous sessions, they will have idea about this. We have done this machine learning model training for multiple times. And then we'll see what is cloud function. For the deployment of our machine learning model into the cloud, we're going to develop a cloud function. We're going to see in detail what is cloud function, and in the last we'll have the deployment of our machine learning model into the cloud. So we'll in this session we'll be using the Python and the GCP platform so to deploy our machine learning model. So my introduction, I am working as a senior AI ML engineer, and I'm also working as a generative AI expert and also doing multiple things, just like I'm working as a data trainer coach and technical writer as well. So if you guys want to connect with me over the LinkedIn, over the Medium, over the GitHub, these are my links. After this session, you guys will have this deck with you, so you can just simply connect with me. Let me give you a recap what we have covered so far in our previous sessions. So the people who are already with us, they will have idea what we have covered so far in our previous sessions. We have covered the future trends of machine learning, how you can implement the machine learning into the industry if you are an industry expert, if you are in the industry. And we have worked on also training your large language model from the scratch. We have seen in our previous sessions how you can train your own data set, your own large language model, so you can optimize, you can fine tune your large language model on your own data set. Also, we have covered the hands-on implementation session on hands-on implementation with deep learning with Python and also generative AI and large language models. So if you guys want to see these webinars, it is available on our YouTube channel. Mudassir can provide you the link after the end of after this session, so you guys can also have a look on those sessions. Those who have not who are not in this in these sessions. So let's start. I'm just going to walk you through with a little bit introduction with the machine learning. Those people who are new with machine learning. So this is especially for those who are already familiar. That's also going to help them. So machine learning is a subfield of AI used for developing algorithms and models that enable computers to learn from the experience. What is experience? Experience is basically your data. You are trying to create a machine learning model who can predict it is a fraud or not. So your experience is your data. You're going to feed that data to your machine learning model. So your machine learning model will understand how the attributes of the fraud person, the person who does the fraud, what are the attributes looks like this. So the experience will be considered as your data. You will feed this and your model will be learning from that. Machine learning is foundation for many AI technologies. ML enables machine to learn from data and improve over the time. Yes. So machine learning has the capability to improve with the passage of time. This technology has the property which can evolve with the passage of time. In the start, whenever you create your machine learning model for the very first time, maybe you won't have that much accuracy, you won't have that much precision in your predictions. But with the passage of time, as the user start interacting with your machine learning model, your model will getting the feedback from the user, and you can incorporate that feedback into your machine learning model, and that will be improved with the passage of time. think of the machine learning model just like a student who is studying from the for his exam from his textbook. He has to go through from each page of his book to become smarter. So similarly, machine learning model go through from each data point to make prediction into the production. So whenever you pass the data, machine learning model get into each entry in your data set. It learn from each entry and make the prediction whenever you make the call this model. So let's deep dive into it. Let me share. So let's have a brief introduction about the Google Cloud Platform. This is one of my favorite cloud platform. I have used around this platform. I'm using this around platform last 3 years. So I'm really fond of this platform. There are a lot of benefits you can avail from this platform. So let's start without any delay. So Google Cloud Platform is a suite of cloud computing services offered by Google that runs on same infrastructure that Google's use internally for its end user products such as Google Search, Gmail, file storage, and YouTube. GCP provides a range of services including computing power. What is computing power? Let's say you have to train your machine learning model into a virtual machine. Obviously, when your data exceeds when a number of data samples, when your size of data increases, you will need the more computation power to run your all the processing of your machine learning model. For this, either you can acquire your own physical hardware or you can just simply use these cloud platforms on on easily basis. So computing power allows you to perform your all the computations not only for the model training but also for the other of the things. Let's say we have to deploy some other application, so you need a compute power, so you can also utilize that. So GCP provides you on prime basis, you can utilize that. Data storage solutions, let's say you have a data and you want to store your data and your data size is increasing rapidly. You're not sure if you acquire your own personal hardware, how much is going to be the data size with the passage of time. So you're not sure your data size is increasing with the passage of time. So in that scenario, you can go with the data storage solutions of the Google Cloud Platform that allows you to store your data on a very minimal cost. And machine learning tools. So Google Cloud Platform provides a lot of tools for machine learning. You have to, if you have to train your machine learning model, you want to fine tune your large language model, what kind of things, if you are training a deep learning model, they already provide you the built-in solutions which you can utilize for your machine learning. It allows developers, researchers, and business to deploy applications and handle computing and data storage needs, scalability and securely. So whatever you store, whatever you process here, it is totally secure and you can scale with the passage of time. Some of the main services you will find on internet about the Google Cloud Platform is Compute Engine. Compute engines provide you virtual machines that runs on Google data centers and worldwide fiber networks. So as I already mentioned, compute engines will give you a capability. You will have your own virtual machine if you have to deploy your any kind of any kind of model. Either it is a deep learning, it is a generative AI model, which is going to require a lot of the virtual machines and lot of computation power. So you can deploy your model here. App Engine, a platform for developing and hosting web application in Google managed data centers. If you have a website you want to deploy on the Google Cloud Platform, you are considering a cloud platform, so you can go with the App Engine that will allow you to just simply host your application into this platform. Google Kubernetes engines. Okay, I'm going to ask guys, do you guys know about this Google Kubernetes engine? That's a question from you guys. If you guys know, that will be great. Otherwise, I'm going to explain you. That's a really interesting thing. You guys must need to learn this thing because this is going to help you in future. So I want to hear from you. I want to know, do you guys know about this or not? Otherwise, I'm going to explain you about this. You guys can type in the chat. Okay, okay. No. Okay, let me explain. So, a managed environment for deploying, managing, and scaling containerized application using Google Cloud infrastructure. So, let's say you have an application, you deployed an application. In the start, the traffic of the application is very low, let's say 200 to 500 users per month. But suddenly, with the passage of time, the traffic has increased with the passage of time. Now you are having 500 users in a day in your application. So lot of people are accessing your application, the load will be high, and maybe your application will crash. So Google Kubernetes has developed a mechanism. So if your application is receiving a high number of audience, high number of traffic, it will automatically scale your application. So it will create containerized applications, and it will allow you to manage multiple users at the same time. So whenever your traffic is high, it will attach more containers, it will create more services, it will create more, you can say, instances. Whenever the number of traffic decrease, it will automatically reduce the number of containers. So with the passage of time, with the your traffic is increasing, it will automatically manage the scaling of your application. BigQuery, a fast, economical, and fully managed enterprise data warehouse for large data scale data analytics. Okay, do you guys know about the what is data warehouse? Same as Docker, yes. You guys know about the data warehouse? Historical data, mostly, yes. Data is stored and managed, yes. Just consider an example of warehouse. What is a warehouse? Warehouse is a place where your all the packages are stored, and whenever the rider comes, they pick the parcel and deliver to the right person. So everything is already ready for to deliver, but for to store for a specific amount of times. So BigQuery is a data warehouse which has the capability to store not only your historical data, any kind of data which could be required in future. So you can just simply maintain your data warehouse using a BigQuery. So BigQuery has their own syntax. It's just similar to the SQL language. So it can be used to just simply manage your all the data of your organization. Cloud storage, scalable, secure, and object for storing any amount of data. Let's say you have to store any amount of data. Your data files are big. You have to store in a space where which is economical, and you don't. It will be safe as well. So you can go with the cloud storage. It will allow you to save your file. AI and machine learning services. Obviously, GCP is always ahead from other cloud platforms in machine learning services. Tools like AutoML, where you can just simply deploy your machine learning models, EA platform for training and deploying machine learning models at scales. So these are the services, main services from the Google Cloud Platform. There are a lot of other services, but these are the six main services for a data scientist and for a data engineer. You should need to learn to be a successful data scientist, because when in industry, all the things are dependent on the cloud. Every organization use the cloud services, so you must need to know these things. The these same things will remain same in all the cloud platform. The name or maybe the flavor will be changed, but the functionalities will remain the same. So being a data scientist, you should make yourself familiar with these things. So I hope you guys learn, have a better understanding about the cloud services. GCP offers a flexible, innovative solution that supports multiple programming languages and integrates seamlessly with various tools and frameworks to empower developers to build, test, and deploy applications quickly and efficiently. Not only it supports Python languages, but it also supports some other languages, like just like if you have to deploy your machine learning model in any language, you can also do this. Not only it is not only restricted to the Python, you can go with other programming languages as well. So that's the introduction about the Google Cloud Platform. Let's go and see the problem statement which we are going to solve. We are we have a data set of the banking sector. They are interested to perform the non to identify the non-performing asset. The bank is facing a problem when they give a loan to the customers. Most of the customers don't pay back their loan. So bank is interested to understand, if I give a loan to this person is going to pay back me loan or not. So this is a problem statement in every financial sector where they deal with lending to the customers. So we are going to train our machine learning model to identify if we give a loan to this person is going to pay back or not. Once we train our model, we are going to deploy this model. And so you can also utilize this model. You can also see how we can make a deployment of your machine learning model into the cloud. So objective is to identify the criteria to approve loans for an individual customer, such as likelihood of the loan delinquency is minimized. So our aim is to we have to minimize the delinquency of the loan, so our bank can also make profit from this one. So we have this data set around 10 plus attributes. So we are going to utilize this data set. We are just loading this data set. We have this data set. I'm not going too much detail about this code because I can assume you guys already know, and there are a lot of stuff available on internet which you can from which you guys can learn. So I'm just going over through these things. So we got the data set, just performing the usual things which we do with every machine learning project, converting the data into the right data type, just creating performing the EDA to better understand about the data. Because when you have to pick the features for your machine learning model, you have to be sure is this feature is making any participation in my prediction or not. So we are just performing this EDA to identify how the people are behaving in this data set. Just checking for the education. Most of the people belongs to the undergrad family. Most of the people have the family size of one. Observation for the securities account. Most of the people don't have the securities account. Most of the people have the online banking facility in their bank. Observation for the credit card. Most of the people don't have the credit card. Nice. And customers credit average spending, it's not visible but we can make it easily visible. Observations of age group, most of the customers we have from 37 to 51 age group. So just doing all these things. Experience, for the experience I have divided into the buckets from 1 to 11 years of experience. We have the 24 percent people. From 11 to 22 we have around 27% people. From 22 to 23 we have around 28%. So most of the people are from years of experience from 11 to 33. Most of the people are coming in this bucket. Income, if we see the income, most of the people in our data set have the yearly income from $33,000 to $83,000. So this is the range of the people we have here. So just performing the personal loan. Personal loan is our dependent variable to give him loan or not. So if we give a loan to the person who has the online banking facility, there one means they will pay back loan, zero means they will not pay back loan. So this is the distribution we can see here. So same, I am going with all the variables. So once I perform the EDA, my next job is to split my data set into the independent and dependent, and then further keep the ratio of 70 and 30, whatever the number you decide. So I'm just splitting my personal loan, which is my dependent variable, and removing the variables which I'm not going to use in my prediction. So I am applying the one hot encoding. Can you guys let me know why we apply the one hot encoding? What's the purpose? Why we need numerical in the features in the form of numerical? Why our machine learning model not take the textual form? Yes, please, Hamza. Mm-hmm. Yes, exactly, exactly. As we know, we have already We already know since our childhood, computers understand only the language of numbers, binary numbers. So it's same with machine learning models. It's a machine learning model, not a generative model, which can understand the textual data. So machine learning models only take the inputs in the form of numbers. So if you have the textual data, you must have to convert into the numbers so your model can understand this one. So that's why we apply the 100 encoding. Yes, yes, Moise, you're right. So we got this data set ready. We are just dropping the unnecessary columns, which is not useful for us. I am just applying a logistic regression on this data set, just checking the accuracy of my model. It is giving me around 95% accuracy on training and 94, which is good accuracy so far if we can use it. And most of the classification is going well, so we can utilize this model into the production. So my recall on the training is good. Testing is bad, but that's okay. We are not here to how to optimize your machine learning model. We're here to see how we can deploy a machine learning model into the production. So once after training my model, I am going to save this model in the form of loan classification model.pkl. Once it is saved, okay, I can utilize this model. So, but before deploying this model, we have to understand what is a cloud function because we are going to utilize the cloud function in to deploy our machine learning model. So Cloud Functions is a really good service developed by the GCP. It is a function, a serverless function execution environment provided by various cloud platforms, including GCP, which allows developers to run backend code in response to events triggered by various cloud services or direct HTTP requests. So let me keep it simple. Whenever you train your machine learning model, you are responsible to deploy into the production, either into the server. You are responsible to check the health of the server in which you deployed this machine learning model. You have to check the number of requests received by machine learning models. The machine learning model should be addressing the every input request by every user. So these are all kind of things you must have to consider when you are deploying your machine learning model anywhere instead of cloud. But as you move your deployment into the cloud, you don't have to worry about any kind of infrastructure. Cloud is responsible for infrastructure, and especially if you go with the cloud functions are serverless. What is meant by this serverless? You guys have any idea about this? What is meant by this serverless? What does this name tells? What is meant by serverless? Any idea what is meant by serverless? I think so. You guys have no idea. Okay, let me explain you. So, serverless means you are not responsible to manage any kind of server. You just have to deploy your machine learning model, and rest of the things will be handled by the Google Cloud Platform. You are not worried when I have to turn on my virtual machine, how I am going to handle my all kind of input request, how my model is going to respond to all the requests. If my number of requests is increasing, do I need to increase the server size? Do I need to increase the virtual machine properties? You are not responsible to do this. Google itself is responsible to do so. This is meant by serverless. You are not here to manage any kind of thing. You just have to worry about your deployment, and rest of the things will be managed by the Google Cloud Platform. So this is the main advantage. You just simply deploy your code, your machine learning model into the cloud function, and cloud function will make sure your code is all the time available 24 by 7 whenever any user make a request to this cloud function. Cloud function will start its services. It will activate all the virtual machines which is allocated to that cloud function, and once the processing is done, it is the job of the cloud function to deallocate all the virtual machines. So you only pay for that specific time in which your execution happens. Whenever you make a request, the cloud function will activate all the services. It will perform the analysis on your input. And once the processing is done, it will turn on all the resources allocated to that cloud function. So your cost is less. You are only paying for that specific type of calculations. So that is the benefit of the cloud function. If you extensively use your cloud function, let's say your cloud function is being used extensively, still the cost is going to be very less as compared to you acquire your own resources physically and you deploy your machine learning model into that, because you are going to manage all kind of maintenance by your own. But Google is responsible for maintaining all kind of things. So consider this thing when you guys will be working to deploy your final year project in somewhere. The right decision to deploy your machine learning model into the production is use the cloud function for any cloud services. So it will make your life easy. You don't have to manage any kind of resource. The cloud itself, the Google itself is responsible to manage these resources. This architecture enables developers to build applications that are scalable. Yes, why it is scalable? Because when your traffic increase, it automatically increase the number of instances and efficient without managing the underlying infrastructure. In my machine, I have a very limited resources, but I have to develop my machine learning model somewhere. I will adopt this kind of platform which can handle my all the requests all the time when it is available 24 by 7. Whenever my number of audience increase who is utilizing my machine learning model, that cloud service will handle all kind of requests and respond appropriately to every input. Here are the key aspects of cloud function in the context of Google Cloud Platform. Event driven cloud functions are executed in response to an event such as upload a Google Cloud storage, when a message or Google pops up topic, or direct HTTP request via HTTP triggers. Okay, let's say Google Cloud function not only used for the machine learning but also can be utilized for the data engineers as well. When you have to create a pipeline to fetch our data, let's say you are working in an environment where you have to fetch the data every day in a specific on a fixed time from external sources. So you can create a cloud function which can at 9 a.m. fetch the data from your desired sources and store into your database. So event driven means you can set the event and at that time the execution will automatically happen. So you can just schedule your time whenever you want to execute this, so it will automatically happen. Fully managed, Google handles all the infrastructure including server management, networking, scaling, allowing developers to focus on solely on the code. Developer only has to focus on the code, rest of the things will be managed by Google. Scalable automatically scales based on the load. Whenever the load increases, as I already mentioned, the scalability also happen. The function instances are spun and down as needed. So whenever the execution done, the service automatically goes down, efficiently handling many requests or none at all. So it can request efficiently all the resources at the same time. Support for multiple languages. It not only support Python, you can create your cloud function in any programming language. Integration, seamlessly integrate with other cloud services, making it easier to extend the functionality of app without managing server. So the when we talk about the integration, it just simply provide you a endpoint which you can just simply utilize in your service, so that will be done your job. Stateless function are expected to be stateless, meaning they execute independently without relying on the eternal state of a function from the previous run. So any state that need to persist should be stored in external sources like databases. So it doesn't depend. The state means when you're first, it's not like then two people called at the same time. When the first execution happens, then the second will happen. It can execute on the same time as well. Billing, you can pay only for the time your function is running. You only pay for the time when your function is running. Even it don't charge you for the deployment. It only charge whenever your function is working. Measured to the nearest of 100 milliseconds, making it cost effective solution for many types of workloads. So if you are considering a deployment where your model is going to be utilized extensively into the production. So you can consider this Google Cloud Platform, where you can just simply deploy your machine learning model into the Google Cloud Function, which can be executed easily. Cloud functions are particularly useful for creating microservices, processing data, and handling webhooks or API requests. They can also serve as a glue logic to connect various services with the cloud ecosystem. Let's go and see. My model is saved. Now my next job is I have to take my model into the production. So let me go to the Google Cloud. So I have created an account into the Google Cloud platform. If you guys also want to create, you must need to have a credit card or maybe a debit card. Whenever you create an account into the Google Cloud platform, they give you around 300 free dollars. So you can utilize that 300 free dollars for the 3 months. I have utilized around $12 so far, and my limit is 13 days are left in my trial. So after this, they will start charging me. But for the 3 months, I think so. If you are creating any kind of POC, if you are creating any kind of your final year project and you want to deploy it in on the cloud, that's the right decision. You can just simply utilize it. No other cloud platform gives you 3 months free. Only the Google Cloud platform gives you this 3 month free. So my model is ready, it is saved in my local. Now I have to deploy it into the production. So I have a code already written for the cloud function. I am going to create a cloud function. Let me show you the code of my cloud function. So this is the code of my cloud function, where I will first save my the trained model into my Google Cloud bucket. So let's go and see how we can do this. So first of all, we are going to create a Google Cloud bucket. So you guys can go to the Google Cloud bucket and you can just simply create a bucket where you can store your file. So I have multiple buckets. I am going to create my new bucket. I will click on the create, and you can just simply set this name. Let's say deploy ML webinar. I will just simply go with continue. Okay, yes, my ML should be in lowercase. You can just simply go with continue. You can keep it as a standard, otherwise it will start charging you high cost. Okay, it is asking you for how many days you have to keep your data recovery. I'm just keeping it by default, but you can read the information you can set based on your requirements. So we are not doing any kind of, yes. So my Google bucket is going to be created. Okay, so my Google bucket is created. In that I am going to create a folder. I am going to name it model. Inside this, I will upload my machine learning model, which I have just trained. Here is my machine learning model. I'm going to load this to the, so it is uploaded. Okay, perfect. So now let me, it is uploaded into my Google Cloud bucket. Now I'm going to search for the cloud functions. So this is the cloud function, event driven serverless functions. I'll click on it. So I have already three previously cloud function. I'm going to create a new cloud function. It asks you to which environment you have to set. Second gen is when you are deploying your deep learning models, and this would be perfect. But as we are simply focusing on the machine learning, so first gen is fine. What is the name of your cloud function? Deploy ML model. Okay, I'm going to set rest of the thing as it is. Save. Next. Okay, now I can write my code here. By default it has shown me the code in the node.js, but I can select the Python. Which version of the Python? I'll go with Python 3.9. So I will copy this whole code and will just simply paste here, and I have my code here. And my second thing is I have to install my all the dependencies, the libraries which I am going to utilize. So these are all my libraries. I am just going to copy paste as it is into my requirements.txt file, because whenever you deploy your cloud function, it installed dependencies as well. So you have to make sure your dependencies are also installed, otherwise your model may be not working. So the entry point, the main function, whenever my cloud function get called, this is my main function which will be executed. So I am going to set this entry point value as it is. So now if you will see, the error is not coming up. So I just have to change the name of the bucket in which my I think so deploy. Oh, my Windows crashed. Yes, there's a problem with Google Cloud Platform console. If you are inactive for a while, it will crash your tab because of the security reason. So let me create again the Google Cloud function. I will keep the name as it is. Next, main.py. In this main.py, I'm going to copy paste my code, and again I'm going to change my endpoint. So endpoint is going to be my predict. So I am going to make a prediction. So let me Google Cloud. Let me change the name of my bucket which I am going to call here. I just have to copy paste my name of the bucket, so then I will be done with, so I can deploy my. This is the name of my bucket, so I will paste it here. Rest of the things will remain same. So this is just simply my code which is loading my model from the bucket. I am telling that this is my bucket. Inside this there is a folder. Inside this folder, this is my model which you guys can also see. So my model will be loaded, and once my model is loaded, I will take the input data in the form of JSON, and I will simply pass to my model, and my model will give me the output of my prediction. So you guys can see this. Let me deploy this. So once I click on the deployment, it will start deploying the model. It will take a while, and once it is done, we'll be able to make the prediction from our machine learning model. It's loading. Still, it's deploying. It's taking a while. So let's move ahead. Okay, so now let's say you have deployed your machine learning model into the production. So what next you have to do? The very first thing is you have to monitor the performance of your machine learning model. Is your model is making the right output as per the expected standards which you defined while before training your model or not? So you must have to consider the monitoring. So monitorings will allow you is your model is giving any kind of error, is any kind of false prediction. So you must have to monitor. Not only monitor but also log your error handling. If your model is giving any kind of error, you must have to log this thing, so in future you can have the idea about this one. Upgrade and retrain, obviously there is a problem can happen with the data when the model goes into the prediction. Sometime the nature of the data get changed, so you must have to keep your data up model updated with the frequent data, with the updated data. So you must have to retrain your model and update with the new data set. Feedback loops that will allow you to approach very well according to the requirement of the end user. If you allow, if you give a mechanism of the feedback, if you allow a user to give a feedback about your model prediction, that will help you to easily fix the improvement in your model. Compliance and security, make sure as you're going to expose your model into the production, make sure obviously model is handling with the data. Is this data is going to be secure or not? Is this going to disturb any regulars, regularity compliance? So you have to make sure about these things. Scale and optimization, you must have to consider the model you're going to deploy is going to be scaled and optimized with the passage of time. User experience, when you're deploying your machine learning model, make it simple as possible, the interface for the user where user can just simply interact with your model. Cost management, obviously you must have to monitor is the production is costing you a lot or not, because sometimes when you don't consider your costing and when you check, these platforms can give you a high cost if you don't monitor your cost. So must perform the cost management to get your optimized resource utilization. A/B testing, obviously A/B testing is always a solution to your most of the problems. So if you compare you do different versions of the model, you can just simply identify which version can easily address the problems of the users. Okay, let me see, it's deployed. Okay, so my model is deployed. This was my code, and we can simply test my model here. So my model takes the data as an input and it takes a list, and I can simply pass this model test this function. So we'll see what's the output of my model in this input. So my model is giving me the prediction of 0. It means this person is not right person for the loan. If my model you give me 1, it means I can give a loan. So see, I train my model, I save my model into the my local, and from my local my model into the cloud platform, so where I can utilize this model not from here, but if you go, this is the endpoint of your model. You can copy this, you can make a request to this model by passing the same input parameters to your machine learning model, so where you can make the prediction on the production from your machine learning model. So this HTTP trigger will be utilized to make prediction from your machine learning model. So that's about for the today. We have seen how you can simply deploy your machine learning model into the cloud. We have seen how we can just simply in few line of code deploy your machine learning model into the production. So your model is available 24 by 7 into the production. This is was the basics. I taught you how you can just simply train your simple machine learning model and make it into the production. Now let's say if you have any use case, now you can keep this as a reference and you can just simply deploy just the same like I did. So if you guys have any question, we can have a discussion about you this what we have learned. Do you guys have any question? Hmm. Hmm. Yes, yes, you can do. Hmm. Obviously आप उसको अपने लोकल में नहीं इतना प्रोसेस कर सकते, so you have the vertex AI, which is a which is a service from the Google Cloud platform. You can utilize that to train, process all your data set, and once your model is trained, from there you can take that model into the bucket and you can create your deployment. Anytime. Yes, 2 TB is normal for the images dataset. But if you go with the Google Cloud platform, Google Cloud bucket, it won't charge you that much high. Yes, please. Yes. Well, it depends on you. I just simply showed you the processing of my model happen in my local. That's the reason you can do these things. Some of the reason, because some of the reason has things so before you the guy asks a question about the images. When this is the case, obviously you need some high resources where you can process all the information. But if you can do these things in local, obviously deployment is also going to charge, so you can save that money. But if you cannot do this locally, obviously you can go with these online platforms and you can do this. There are yes, yeah, that's why I'm saying that if you can go for some other online platforms, you can go with that. Then you can come to the for the deployment. You can come here and you can simply deploy anytime. Guys, any other question? PySpark in Databricks. How can we use PySpark in Databricks for the deployment of the model? Okay, so PySpark, Python also, the Google Cloud Platform also support the PySpark. But if you are mainly concerned with the Databricks, you can go with the Azure Cloud Platform. So same you can go with Azure Cloud Platform. Azure, I think so gives the free 1 month credits. So if you want to utilize that for the Databricks, if you're concerned with the Databricks, you can go with the Azure. Azure, because Databricks is main towards the Azure. Most of the people who utilize the Databricks, they go with the Azure services. Any other question, please? Mhm. Obviously, this is the need of the hour. Right now, data scientist is mainly towards also responsible for working towards the analytics side, processing side, machine learning side, and AI is mainly towards also responsible for deployment. Is also responsible for maintaining all of the services of your AI. Data scientist only train a machine learning model and just simply pass it to the rest of his team. They are responsible to do that. But most of the things are alike in both things. It is. Hmm. But most of the things are alike. If you have 1 year of experience as a data scientist, you can also go with the job title of AI. Those things are same, but being a AI engineer, your just scope get more broad anytime. So guys, if you don't have any question, I have a feedback form for you guys. If you guys can answer this question because I receive lot of questions on my LinkedIn and I don't have time to answer everyone. So here is your feedback form. You can just give us feedback how our sessions are helping you. So our next sessions we can design based on your feedback. So I'm just sharing this link in the chat so you guys can give us feedback. What do you do? What do you do next to transform this from a pickle file to something usable on Google or a website for web app? Even your website or a web app, you can still use this PKL file. You can just simply reference this file. You can pass the input to this file. Yes, you can get the old recordings of older session on the link our YouTube channel. Maybe Mudassir, can you paste the link of the YouTube channel here? Here is the link. I got it. So Mariam, here is the link. You can check the previous sessions anytime. Okay, I think don't have any question, so we can end this session.